Hearty welcome to the online problem solving session series organized by mass aspirants groups. Today we have a session on metric spaces, which is actually the continuation of the previous session. We have Mr. Abhirup Das, research scholar, TCG CREST, Kolkata, as the resource person for today's session. I welcome everyone to this program and request all of you to be actively involved in the discussions and be there throughout the session. So I welcome Abhirup to handle the session. Welcome, Abhirup.
Yes, very much. Thanks a lot to you, sir, for giving me this opportunity. Because, I believe in today's world, reaching people is a tougher job than learning mathematics, to be honest. So, you have given me this opportunity. So, let's see. I will try my best to make use of this 1.5 hours so that I can give something worthwhile to those who are actually who have been kind enough to be attending this session. Okay, so let's start. Okay, so this is our first question. Okay, let I be an interval, so it can be closed, bounded, it can be open, and if I to R is continuous or injective on I, okay, then if I is an interval of this form. Okay, these are very small problems. It won't be very lengthy. So without loss of generality, let f be increasing. Okay. Now let C belongs to. So if A is increasing, we have that f of A is strictly less than f of B, right? That much we have. Now take C belongs to fa, comma f. Since f is continuous, by intermediate value property of f, we have a d in A, comma B such that if D is C, right? That is right. Okay. So what do you get? Observe carefully. What do you get? So what you get is that every point in this interval, what you get is that every point in this interval is basically nothing but an image of this point. A point here. And C, there can be only one pre-image because f is injective. Okay. Hence, we have the first result that f of A, comma B is basically f of A, comma f of B. Right? Because you see, if FD is C, then of course, where does C belong to? C belong to f of A, comma B, right? Okay. So this was our first problem. Feel free to ask questions. Okay. Every question, every query will be entertained. And similarly, you can prove for the closed cases. Okay. And if it is decreasing, then you can, then FB and FA will just swipe places. Okay. Let's see the next. So if I is an interval and IR is a continuous and injective map, then F is strictly monotone on I. The question is clear? Continuous plus injective is monotone. So let's draw a picture. Okay. Okay, so suppose, I mean, if possible, maybe say, suppose not. That is, there exists x1, x2 belongs to I, such that if x1 is equal to fx2, right? Because f is not monotone. So you see, how will it look like? So x1 is here and x2 is here. Okay. You see, suppose fx1 is here. I mean, this is the point, say x1 comma fx1. This is the point, say x1 comma fx1. Okay. Now you see, no, actually, no. I mean, I'm doing a step jump here. I mean, I'm doing a step jump here. Okay. Just a minute. Suppose not, then there exists x1, x2, x3 belongs to I. Sorry, I did a step jump. Let's break it even further, such that x1 less than x2 less than x3, but fx1 less than fx2 and I mean, this should be the case, right? If it is not monotone, then there should be something like this, nah? I mean, x1 less than x2 less than x3, but it doesn't mean x1 will be less than, is less than x2 is less than x. I mean, there will be one inequality that will be reversed, right? So x, y, x1, x2, x3. Suppose this is the point fx1, x1 comma fx1. Okay. So fx2 is largest, say is x2. And then there is again x3. So you see the graph is continuous. You just draw like this. Okay. You see the injectivity is hampered, right? Because you see these points. I mean, there are these points. All along these points, you are getting two pre-images, right? Suppose you take this point here. You draw the line here. Now you see you are getting two pre-images, right? So this is, say, Z1 and this is Z2. And as you can see, Z1 and Z2, that is FZ1 is equal to FZ2, right? Right? That is good enough, I feel. So you can actually write it down. I mean, it's not a, just a minute. So it's not a very rocket science to write. So according to our picture, whatever we have written, without loss of generality, we assume that fx3 is the least of them, right? Okay. Now, you see where this point is chosen from? You see. So this point is chosen in between fx2. You see this point, okay? That is, I mean, say C, okay? Which, I mean, C is our fz1 equals to fz2, okay? So, see, analysis is basically writing down a picture, okay? But you have to write it properly. So, C, you see the interval in which C is chosen. So, this is your fx2, right? And this is your fx1, right? So, you have to choose C from fx1 from into, I mean, from. So, now choose C belongs to fx1 comma fx2, okay? And you see automatically, because of this inequality, this is strictly contained in fx3 comma fx2, right? So by IVP, we get Z1, where see where Z1 is in that interval x1 x2, right? Belongs to x1 x2. Z2 belongs to where x2 x3. Such that f of Z1 equals to C equals to f of Z2, which is a contradiction, right? Because f was given to be injective. Okay. Thus 2 is also proved. Let's move on to 3. We will prove it, but for the time being, we will not take I to be closed bounded. Okay. Let's not take I closed bounded, and let's see if we stuck. If somewhere down the line, if somewhere we are stuck, let's see. Let's not take closed bounded for the time being. So let me first define a notion. Open maps. Do you know what an open map is? So if I to R, where I is any interval now, is called an open map if sends open sets to open sets. That is, for U open in I, if U is open in R. Okay, that is the definition. Clear? Remark. Okay, let's put this remark as a question. Suppose this is given, huh? Suppose if AB is open for any A, B belongs to I. Can we say that F is an open map? So you understand the question? The question is, F only sends open intervals to open sets. Since F is continuous, since F is, all along our discussion, F is assumed to be continuous. Okay. So of course, you know that if A comma B is going to be an interval. Okay. And now we are saying that if A comma B is also open, by that we mean if A comma B is also an open interval. Is that enough to assure that F will be an open map? That is, will F send any open sets to open set? What do you think? Any intuition? Yes, no, anything? Tista, are you there? Hmm. I say yes. I say yes. I think you have come across a result in your BSc course which says that if U is open, then U can be written as disjoint union. This is the notation for disjoint union of AI BI. I belongs to natural number. That any open set is a disjoint union of open intervals, of countably many open intervals. Okay. So once you have that, you can just apply F over that. Since F is injective, this disjoint union will be distributive with respect to F. Okay. And all of these are open sets because of this. Okay. So FU is also open. Okay. This was our remark 1. Let's move on to remark 2. If I to R continuous and open. So F is a continuous map which is also open. Then F inverse wait a minute, what have we proved this for? So you see, you look at this, okay? From 1, we have that if F is continuous and injective, then F is an open map, okay? Right? So remark, maybe I should write remark 2 here. By problem 1, if F is continuous and injective, then F is an open map. Okay. So this is remark 3. I mean, we have all the above. Okay. F is continuous injective, hence F is open. Now, F inverse defined from FR to R. Since F is injective, the inverse is well defined. Is also continuous. So how do we prove that? The proof is actually one line. You know that F is an open map, right? And also you know that F is injective. So take U subset of I, which is open. Okay. We have to show if inverse of U that is open in Fi, right? That's what we need to show that F inverse is continuous. But you see, what is this thing? F inverse is Fu, right? That is F. But that is true because F is an open map. Thus, F inverse is continuous. Okay. I don't know whether they have given this problem or not, but let me add something. Then G is strictly monotone, G is strictly continuous on J. Yeah. The differentiability problem, they've missed it. Okay. Probably lost it. Thank you. Remark 4. If f is differentiable, then f inverse is also differentiable. Okay. So one thing we know that since f is injective, okay, since f is injective, f prime x is not 0, right? Or maybe I should write if prime x is strictly greater than 0 or strictly less than 0 for all x belongs to I, right? So without loss of generality, since we are taking f increasing at every step, without loss of generality, f prime x is strictly greater than 0 for all x belongs to I. So what will be the derivative of x inverse? What will be that? So let y equals to maybe not y. Let's c equals to f of d belongs to fi. Okay, and we want to check whether limit k tends to 0. What am I trying to do? F inverse. I'm trying to check the differentiability of f inverse at c, right? Yeah. So c plus k minus f inverse c by q. Does it exist? So let's see whether it exists or not. Since k tends to 0, choose k so small that c plus k is inside I. Okay. Sorry, c plus k is inside the interval fi. So there exists h greater than 0 such that c plus k is nothing but f of d plus h by IVP, right? Is this line clear? Is this line clear? So it's nothing, okay. I am just taking this. I mean, c plus k is in f plus I, right? So c plus k has a pre-image. Let's simplify it even further. Implies there exists d prime belongs to I such that f of d prime is c plus k. Okay. F of d prime, you put c equals to fd here, minus fd equals to k is greater than 0. So fd prime is greater than fd. This implies d prime is greater than d because f is injective. Since f is injective, f injective. Okay. Set h equals to d prime minus d. Okay. Then we have f of d plus h is f of sorry, c plus k. Okay. Put them here. So in star, you replace them, you get limit k tends to 0 f of f inverse of f of d plus h minus f inverse of f of d by k, that is limit k tends to 0 d plus h minus D by K. Okay. Clear? Okay. So now you see that what is K? So K is f of D plus H minus Ft, right? Right. So my goal is to my goal is to wait. It was that okay. Just a minute. Just a second. I want to do it on C, right? That was C equals to Ft. So I want to do 1 by F prime. That is my goal, right? Okay, just write it down, nothing else. So you just write limit k tends to 0, 1 by, put the value of k, f of d plus h minus f of d. Okay, take h below it. Okay, that's it. And you see, h tends to 0, it will imply k tends to 0, right? Because f is continuous, as f is continuous, right? So you can replace the limit here. That is, you have 1 by f prime. Okay. So you see, if inverse, this was supposed to be what? This is supposed to be f inverse prime C, right? And we have defined that. Okay. So D was probably f inverse C, I think. D was f inverse C. Thus, we have proven that f inverse prime C is 1 by f prime f inverse C. Okay. So you get that, I mean, f inverse is also differentiable at every point. Okay. So if f is differentiable, injective, continuous, I mean, then f inverse is all those things. Okay. Let I be closed, right? So let's do 4 and 5. Remember everything that we have just did. Okay. Because I mean, these two are sort of, I mean, these two are okay, but we won't need 4 and 5 to go to 6. Our main goal is 6. And whatever we have proved this far is good enough to go to 6, but let's do 4 and 5 again, because I mean, see, I mean, since we are talking about injectivity, monotonicity, so let's talk a few more words regarding them. So So the question is like the following. Okay, so this is our goal. We want to prove that if f is a function from closed bounded interval to R. Okay, I will just request you to observe one thing. You see that we did not need that closed and bounded interval and all those things. We didn't need. Okay. So for closed and bounded, we would have used a different technique. But taking I as an interval actually gave us a few more facilities as well. Okay. So R is intermediate value property. Is injective, then it is strictly monotone. The continuity is not there. Okay. Let's do that. So we want to show that f is strictly monotone. Solution. So x1 less than x2. Let x1 is less than x2. So f is injective, thus fx1 cannot be equal to fx2. Okay. So if f is not monotone, there exists x3 belongs to a comma b such that x1 less than x3 less than x2, but just like before, fx1 less than fx2 and fx3 is less than fx1. Okay. Is that right? Is that right? So it is not monotone. So it is not monotone. Thus, it is not monotone. X1 less than x2. We have to show that if it so x1 and x2 is arbitrarily chosen. Now what we are trying to show is that yes, that's right actually. That so if x1 is suppose here, just a minute. If x1 is here, if x2 is right here, if x3 is let's somewhere. Hmm. So by IVP, there exists C belongs to C. I don't actually see worked up solutions. Okay, I don't prepare solutions before coming to this class. Then it becomes very boring for me. So it is very much possible that I will be making some silly mistakes here and there. Huh? All along my life, I have been making those. So if you notice one of them, if you notice any, just feel free to point it out. Okay. So by IBP, there is an C such that FAC is fx1 I think it should have been oh, so fx1 should be in between these two, right? Fx1 is less than fx2 and fx1 is greater than, yeah, right. So you see, this contradicts the injectivity, right? Right. Because x1 is here, x2 is there, x3 is somewhere here, and C is here. Okay. So that contradicts the injectivity.
I mean, how? We have assumed that it is not monotone, right?
Yes, yes, yes.
So how can we claim that it's not injective? I mean, it can be true that they both are equal, right?
You are saying that if C and fx1 can be equal, right?
Yeah, like we have
Sorry,
claimed that
C
it is
and
not
x1 can be
monotone.
equal, right? Yes, but injectivity is given there, na? So, okay. So you are right, actually. I think I need to write a step further. So C equals to x1, right?
Yeah, I mean that it is violating that C equals x1, not f of C equals f of x1, right?
Yeah. It's violating that. Yeah, you're correct. Revati, I think it is right. I hear your voice. I think I
Yeah,
recognize
yeah.
your voice from the last class. Okay. Good. I think that you will find the problems is very interesting. Okay. Because I don't think that a mathematics course is taught in this manner. I mean, I'm sure, sir teaches in this manner, but I mean, that is not a usual culture. Usually, we are trained to study more and think less. But I mean, I'm sure sir definitely encourages his students to think more. That's why this whole group, that's why this initiative and all that. Okay, so I is again satisfying the intermediate value property. I mean, if you satisfy the intermediate value property, if is injective, then if is continuous. So they are saying that following IVP and injectivity is enough to for us to conclude the fact that F is continuous. Okay. Now see, whenever we take epsilon, we say that for every epsilon, okay? But there is something written in the bracket, however small, okay? It's enough to take epsilon, I mean smaller. So take epsilon greater than 0 without loss of generality. Let epsilon be less than minimum fx minus a comma b minus fx. Okay. Now see, we already have fa less than fx less than fb, okay? Because f is injective. I mean, we have the monotonicity from the last problem. Okay. So now you are getting that if a is less than f of x minus epsilon less than f of x plus epsilon less than f of b, right? Right, because fx is inside fa and fb, right? We have chosen the epsilon in a manner such that this fx minus epsilon and fx plus epsilon. Okay, let's just write another line here. Okay.
Sir,
Yes.
I think it must be minimum of f of x minus f of a and b minus f of x.
Yeah, what have I written? Oh. Thanks a lot. You see, when if you're surely you will take some classes in future. It's very refreshing when students point out mistakes. It means they are actually seeing stuffs. Because I mean, it is very hectic for a teacher to look at a white screen and just go on for hours. Yes, this is the inequality. Now by IVP, you have x1 and x2 such that if x1 is equal to fx minus epsilon and fx2 equals to fx plus epsilon. Okay, and you know that x1 is less than x2 because of the monotonicity. Okay, the monotonicity is there. Now consider delta to be minimum x2 minus x comma x minus x1. So x minus delta comma x plus delta is inside this interval. In fact, inside the open interval. Okay, so that is enough. You apply f. See, f will send intervals to intervals because f is follows IVP, right? You have f of x1 comma x2, that is a subset of fx minus epsilon comma fx. Okay, there is your continuity. Now we move on to the last part of this class, but before that I would ask you guys to look at this, just this result and nothing else. Just a minute, let me minimize this screen. Tell me when you are done. Okay, you need to look at this problem and the 4 remarks. Okay, I am giving you guys 1.5 minutes to look at this problem. Just statement, nothing else. Just remark 1, 2, 3, 4. That's all you need to check. Okay? Remark 1, remark 2, remark 3 and remark 4. That's all. That is all. I'm giving you just 1.5 minutes. Look at it.
So can you please scroll down to page number 3 once?
Yes. Is there a question?
So page
Hello?
number 3, the last page that you just finished
one?
writing.
Huh?
The page after this, where we were doing the last question. We were discussing the last question. Yes.
No, I don't need these things actually. I only need those remarks. That's it. Okay. So that brings me to the final part of our discussion. So question 1. Question 6. How do you define log x? Is the question clear? First tell me that. Revati, is the question clear? Okay, so let me elaborate it for a moment. Forget part B for the time being. Just concentrate on part A. Okay. So we all know that. I mean, here we are taking basic. Huh? So by that we mean, so how do we define log x? I mean, so we all know that log x base e equals to y if and only if e to the power y is x, right? So what guarantees us about this existence of y? What guarantees us that there is a real number y whenever we take a positive x such that e to the power y is x? What guarantees us? Because you see, I mean, if x less than 0, then no such y exists, right? That was pretty direct, I think. That because if e to the power y is x, e to the power y is x, that can never happen, right? Because e to the power y is always positive. So for no negative x or even 0, such an y exists. Then who gives us the guarantee that whenever x is positive, we have this y? You understand the question? So the question is, what guarantees us the existence of y? Anyone? So how should we define log x? Forget about the definition. Is the question clear to you guys? Because see, we have been using log x since class 9 probably. Suddenly, after all these years, I'm asking you, how should I define it? So you are bound to get a little bit shaky. But is the question clear? Hello, is the question clear? At least I'm expecting some sort of a response from your end. Otherwise I can't proceed. I don't think this is quite clear. So what I'm asking is that, so when you write log 10 base e, what I mean, you are assuming that this whole thing is in the real number, right? What guarantees you that this is in the real number? That's the question. Okay. This may be a complex number. Such a thing may not even exist. Like log minus 10 base e, it does not exist. Okay. Okay. So what you can do is that you can first define e to the power x from real number to 0 infinity. Okay. And you know that e to the power x is continuous, differentiable,
Like it is
injective.
very obvious, right? It is on R. Like if it is on Z, I mean complex numbers, which you were saying, then it has to, I mean, that should be the combination of two variables like x, y.
Why? Can't I write e to the power I 2n pi is equal to 1? So just like you said that y should be in reals, okay, you see, to have e to the power y real, you don't need y to be real, right? And in that case also you are assuming that such a number exists in the complex plane, then you are reaching the contradiction, right? There might not even be a complex number such that e to the power, I mean, again, there is not a complex number such that log 10 is y, okay? E to the power y is equal to minus 10 for no complex number y even, okay? So just because e to the power y is real, don't assume that y is real, okay? Revati, the question, I mean, is that clear to you now?
Yeah.
So you see, e to the power x is continuous, differentiable, and injective, and we know that it has an inverse, right? Which is also continuous, injective, and differentiable by our last problem. So define log x base e to be the inverse of e to the power x. Okay, that's pretty direct. But now is the next catch. How do you define e to the power x? How do we define e to the power x? How do we define e to the power x? Is my question clear? Don't tell me that multiply e x times, because that doesn't make sense. How will you define e to the power root 2 or even e to the power pi? Is the question clear? Okay, just think about it for 30 seconds and then tell me whether you think that this question is utter nonsense or not.
So can we put e to the power x where x equals to a negative number?
Why not? Why not? E to the power 1 by e is there, right? So that is the inverse. Why not? E to the power x is defined for every real value x. But I mean, how do we define e to the power x? That is the very basic question, right? What do we mean by raising e to power x? What does that even mean? Because you see, I mean, one thing is clear. You can, for n belongs to natural number, e to the power n, you can define it like the product of n is, right? Right? And u to the power 0 is of course 1 by definition. E to the power minus n, you can define it to be what? 1 by e to the power n, once you have defined it, right? Once you have defined e to the power n for positive n, you can define e to the power minus n, right? So e to the power x, I mean, say e to the power n is defined for all n belongs to z, okay? But what about the other real values? How do we define e to the power 3 by 4 or even e to the power root 2? Is the question clear to you? I think the question is more important than the solution.
Sir, can x be the one of the, I mean, can we put x as a complex number, sir?
I'm thinking. So first let's define it for x. Okay. First let's define it for real. Okay. And then we will go to complex. Okay. Because see, when you take z x to the power iy, you know how to define it, right? You know e to the power z, you can just define it like e to the power x into e to the power iy. Okay. Where e to the power iy is cos y plus I sin y. Okay. The trick is to define this part, not this part. Okay. So tell me, how can we define it? Revati, can you define it for the rationals? I'm not entirely sure that whether whether my message is getting across to you. I mean, tell me something. Can I move on?
Yes, sir.
Okay. I understand the thing actually. You guys are probably facing this for the first time. So yes, I mean, there are bound to be some problems. Okay, so let's do that. Okay. So first, let's try to define for rationals. Okay. So take P by Q, which is greater than 0. See, because once you define for positive rationals, we are just going to take the reciprocal and define it for negative rationals. Okay. So how to define e to the power P by Q? Okay. So I can guarantee that you guys will just say define it for this. I mean, what's the problem, right? E to the power P is defined, right?
Yes, sir.
But the problem is, again, how do you know the qth root of e to the power P exists? Who told you that the qth root of e to the power P even exists? Why the qth root of a positive number exists? So now what we do is that we define a function if q. Okay, this is from 0 infinity to 0. Okay, you send x to the power q. Okay, now see, x to the power q is defined, right? Because q is an integer, right? Q is an integer. Pq belongs to natural number. So q is an integer. You can define x to the power q just by saying product x q times. Okay, and if q is of course continuous, right? Because this is a product of q continuous functions, right? That is product of identity functions q times, right? So if q is continuous, and you also notice that if q of 0 is 0, and limit x tends to infinity, fq of x is infinity, right? Right?
Yes, sir.
So for any c belongs to 0 infinity, we have d belongs to 0 infinity such that if q of d is c, right? That is d to the power q equals to c, right? Because of IVP. There we are using IVP. Okay. Now choose c equals to e to the power p. Okay. So you have a d such that d to the power q is e to the power p. Okay. Define e to the power p by q to be what? D. And also you observe that if you differentiate fqx, fq prime x, what is it? Qx to the power q minus 1, right? Which is strictly greater than 0 for all x belongs to 0 infinity, right? Which means that fq is injective, right? So fq is injective, right? So fq is injective, which implies there is unique such d. Because you see, I mean, we will have to define the well-definedness. If there is d and d prime, which one should I take? So because of the injectivity, that dilemma is no longer there. Okay. So now you can define e to the power p by to whole to the power 1 by q. Okay. So we have defined it for rationals. So e to the power x is defined for all x belongs to q. For positive rationals, we have defined it. Just take the reciprocal. What about the irrationals? How will you do that? What if x belongs to r minus? What will we do then?
I think taking continuity on rational sequence.
Okay, so he is saying that, sir, you just take limit n tends to infinity e to the power xn and define it to be e to the power x, right? You are saying that, I think, where xn goes to x and this xn are in q, right? That's what you are saying, right?
Yes.
But you see the problem is that who told you that this will converge? That is our natural intuition. Okay, but who told you that e to the power xn will even converge? Xn converges. No. Yeah, very good. So that is the first misconception that we make that at this stage. Okay, see, he is saying that xn goes to x should imply e to the power xn goes to e to the power x. But what you are forgetting is that e to the power x is not yet defined. Forget about the continuity at x. We are not being able to define it at x. Okay, once you have defined it, then only you can talk about continuity. But we don't know that what e to the power x is yet. So basically what you are doing is that, you see, to define e to the power root 2, you are assuming that e to the power the function e to the power x is continuous at root 2. That is not even, I mean, that doesn't make sense. That is the fallacy. We are trying to define it. Okay. So to bypass this, we will do something. See, we have this, right? So if r and s belongs to q, with r less than s, we have e to the power r less than e to the power s, right? That much we have. Okay. Now consider this sequence. Call it tau x. e to the power r, okay, such that r belongs to q and r is strictly less than x. You understand the sequence? You understand the set? We have taken all the rationals which are less than this irrational number x, okay? All the rationals which are less than this irrational number x, we have raised them to the I mean, we have computed e to the power r, and we have collected this set, okay? Because these terms are defined, right? E to the power r is defined for r rational, right? Now you observe r less than x, right? Less than box x plus 1, right? This term is in q, right? This box x plus 1 is in q, right? So we can say this, right? For all r less than x. Revati, understood? There is no fallacy here. Okay. So tau x has an upper bound. Define e to the power x to be supremum of tau x. Clear? Clear? Now you see the sequential criteria is there. If you take a sequence Rn which goes to x, you will see that e to the power Rn will go to e to the power x because of the way we have defined it. This is a supremum. Clear? Is that clear?
Yes, yes.
Okay. So I have a question. So you see, to define log x, we almost ran out of steam. Can we define log x? Can we define log x without using e to the power x? Can we do that? The answer is yes. So define log x to be 1 to x 1 by tt. We all know that the integration will be log x, right? We all know that. But see, there are things we need to check actually. First, we need to check that whether this is the inverse of e to the power x or not, because you can just define it log x and then, I mean, it should agree to the to our usual notion of log x. Now, we should have to show that indeed, I mean, this is the inverse of e to the power x. This is different. I mean, you can see the differentiable part is there, right? Because of the way we have defined it, the continuity, differentiability, everything is there, right? From the fundamental theorem of calculus, right? So from the fundamental theorem of calculus, log x defined as, call it double star, is differentiable, right? 1 to 1 and everything else you can check. Just check log x equals to log y integrate. I mean, then you will realize x equals to y. The question is, but is it the inverse of e to the power x? My handwriting is horrible. Let's check. So first denote. First denote okay, just say that. So first denote fx by log of e to the power x. Okay, we will try to show that this is indeed x. That should be the identity, right? That should be the identity function, right? So let's see what happens. So fx by our definition log e to the power x is 1 by e to the power x 1 by t dt. YOLO. Now what should be our next step? What should be our next step? We can define it actually. We can take the derivative. That is one way to do it. Yes, I think that thing can be done. So what will be f prime x? You know that by that integration under the differentiation sign by Leibniz rule, it will be right. That is the thing, right? If you have fx like from theta x to psi x, from you are integrating it on gt dt, then by Leibniz formula f prime x is what? G of psi x times psi prime x minus g of theta x times theta prime x. So that's what we have done here. So you see f prime x is what? E to the power x times e to the power x minus, this is 0, this is 1. Okay, so f prime x is 1. Okay, which means that fx is x plus some c, right? Some constant. C is constant. But what was our fx plus c, by the way? So fx is x plus c, right? So that means if 0 is c, right? What will be f0? You put it here. So f0 is by our definition log of e to the power 0, which we define to be this, right? but this is 1, right? Hence the integral is 0 because integrating 1 to 1. Okay, thus you have c equals to 0. Okay, so now you have fx equals to x. Okay, so indeed you have log of e to the power x is indeed x. Okay, so now we have defined log x without actually going into the details of how to define e to the power x. But again, you see, we have used e to the power x here. Okay, we have used e to the power x here. But just we didn't use the fact that e to the power x is injective and continuous and all those things. We just escaped that part. Okay, so by that, I will conclude today's class. Okay, so
Sir,
that's
hello, sir.
yeah.
Sir, I have a doubt, but
Yeah,
related
go
to
ahead, go ahead.
matrices. I have already sent this question to group. Can you please check, sir?
I mean, regarding what?
Regarding matrices, I mean eigenvectors.
I think we can just restrict our discussion for this session to the content I have right now. Else you can send it there, and I'm trying to answer there. Okay.
Okay, sir. Okay. I've already sent this question. You please send this, I mean, solution in group.
Okay. Okay.
Sir, I want to ask one more thing. Is this is this session is helpful? What are you? I mean, this course is helpful for JAM and CSIR net. Is it?
See, I think we had a little bit of a discussion in the last class regarding this. Certainly, my sessions are not. I mean, not my sessions actually. I have dedicated sessions for CSIR net and JAM in my academy. That is different. But this particular sessions, you can check the heading of the assignment. These are for MMath. Okay, so those that I have discussed today will be probably you will face these questions more in in the interviews. So this won't help you solve MCQs directly actually. That is not so if you are just looking for MCQ solving techniques, these sessions are not meant to help you. We will have those sessions. Okay, before every CSIR net I will try to conduct a few sessions with sir. Before JAM I will try to conduct a few sessions with sir. But these sessions, these are meant to serve the MMath purpose and not the MCQ exams explicitly.
Sir, will you provide that session also in this group?
Yes, why
JAM
not?
session?
Yes, why not? Before JAM, I mean, sir actually asked me to do that before JAM, but I was in so much mess in November, December, January that I couldn't come up with anything. Just.
So you mean this course is helpful for ISI?
No, you don't. Okay, so let me tell that. So first of all, JAM is a subset of ISI. Okay. So once you learn, first of all, I don't believe in this sort of things like for JAM, for ISI. So just like you can't prepare a batsman only for T20, only for one day, only for Test cricket. You can prepare him for cricket. So that's what I believe in. So what I try to teach is that first we will go through concept by concept. We will solve textbook, say Hoffman-Kunz, Bartley-Sherbert, matrix based from Rudin, from Hungerford, abstract algebra, and all those things. Once those are done, then for the last 20% of the course, before every exam, we will keep them for problem solving. So before JAM, we will do a lot of problem solving for MCQs and all that. Before ISI, like we are doing problem solvings. But before, I will teach you mathematics. I won't teach you MCQ. But that doesn't mean that I won't guide you to solve an MCQ. Of course, I will guide you. But MCQ solving is a subset of learning mathematics. That's what I'm trying to say. So you see, when you are in school, which board you are in? I mean, if you just don't get up. Sorry.
BSc in mathematics.
No, which board you are in? I mean, from class 12 CBSE.
NAP 2020.
No. Which board? I mean, CBSE, ICSE, your school. I mean,
It's CBSE.
CBSE, right? So,
Yes.
how did you prepare for your exams? So, you pick up a textbook, you solved it. You pick up the reference book, you solved it. Then you went to the PYQ, right?
Yes, sir.
But have you ever done that? Let's solve the NCRT. We know the theories now. So, let's now directly move on to the PYQs. Have you ever seen a guy who has just solved NCRT? He knows the theory, and now he's trying to go for IIT JEE Advanced. So that's not the way. That's not the natural way. That's not a way at all. Okay. And this might offend. Okay, so let's be politically correct for the time being. This might offend a lot of educators out there. I don't give. I really don't give. I will true to be. I will try to be true to mathematics. That's it.
Okay.
So
sir.
just like school level, we solved. I mean, there was not a way. I mean, suppose you are asking your teacher at school level, sir, I have solved NCRT. Can I just solve joint level questions? He will probably do you a guardian call, that call your parents and let me talk to them. So it's like that. It's never the way. But somehow what happens is that when we have moved on to the college level or university level, the habit of reading textbooks, it's sort of vanished because of the note taking, note remembering, and note producing culture in the examination hall. So that's why we struggle so much in the competitives. So what we will do is that we will train you. First, we will train you through our textbooks, and then we will, of course, train you to do MCQs, because that is bread and butter for a mathematician in India. You will have to be good at MCQs. I wasn't very good at MCQs, you know. I mean, I cracked TIFR first, ISI first, then I cracked NET. I mean, NET was, in fact, my rank in NET is not very good. It was 114 only. Okay, but I mean, in ISI, I was in probably the first 12 or 13 in the written exam. TIFR, I was in the first 26. But I really struggled to clear CSI and NET because MCQ was never my cup of tea. So you will have to learn it, because I mean, you will have to get the stipends for that very reason. You will have to survive, but don't. That is bare minimum, but that shouldn't be your goal. That's all I can say.
Okay,
Yes, sir.
sir.
What do you, sir?
Okay, thank you, Abhirup, for today's session. I think the time is almost exhausted.
Okay. No issues.
Yeah,
I will send the recording and the notes as well.
Okay.
Okay. Thank you, sir.
So, yeah, let us wind up here.
We will have probably at least one more session. 2 more if I can. Let me see if I can manage. Okay, so I will let you know. I will know, sir.
Yeah,
Let
sure, we can arrange. Sure, we can arrange.
Okay. Thank you for tolerating me. Okay. Again.
Thank you. Bye.